All right, we're moving on, or getting started. I mean, the only thing we did before was review of algebra, just made it really hard. So now we're getting into roots and radical expressions, and I'm going to start with these 5 examples to walk us through kind of how square roots operate and basically how roots operate, basically. So I have questions. Sometimes I'm asking about taking the square root, sometimes the 4th root, sometimes the cube root. So a bunch of different roots, which might lead you to wonder, well, how many roots are there? And, well, there's a bunch of roots. There's an infinite number of roots. Okay, so it all depends on what's called the index, and I'll get to that as we go along. So I think the best way to do this is just to jump right in. Let's start simplifying stuff. Let's find out what's the square root of 0.0081. Okay, so when we look at number 1, sometimes I'll ask you to find a root of a decimal. And so basically, we're looking for the square root of 0.0081. And you have to remember what the square root asks. Okay, so the square root is actually asking a question. The square root asks, what times itself gives you the number inside? Okay, so what times itself gives you the number inside? And that's what you have to start thinking about. Okay, so we have the square root of 0.0081. Basically, you're asking what times itself gives you 0.0081. And so you focus on the 81, and you're thinking, well, I know the square root of 81 happens to be 9. Okay, so you might be thinking 9, but that's not correct because 9 squared is 81. It's the square root of 81 is 9, not the square root of 0.0081. And so you might have to start thinking about decimal places, and decimal places are really concerning, and you have to be careful with it. So what instead of 9 times itself giving you 81? What if you would consider a decimal place? We know 9 times itself is 81. Well, what is 0.9 times itself? See, 0.9 times itself is going to be 81, but with 2 decimal places. 0.9 times itself is 0.81. So you might be thinking that the square root of 0.0081 is 0.9, but that's also not correct because 0.9 times itself is 0.81. Well, this is interesting now. So what about 0.09 times itself? Okay, so now we got to consider 0.09 times itself, and 0.09 times itself will give you 81, but with 4 decimal places. How cool is that? Right? It's 81 with 4 decimal places. So we have to consider sometimes decimal places and decimals. I mean, the very foundation of mathematics and arithmetic is knowing your places. So clearly, the square root of 0.0081 is equal to 0.09. And that's what square root is all about, asking you what times itself. Okay, so that's kind of how we would approach number 1. All right, so the square root of 0.0081. So now we move on to number 2. Well, let's find the cube root of negative 64 over 125. This is going to open up a couple of issues. So we're looking for the cube root. Now, how do you write the cube root? What is the symbol for a cube root? It's this. This is the symbol for a cube root. And that little 3 is called the index. Okay, so the index is 3. Man, if I had a better pen, that would be even awesomer. So the index is 3. I'll write that in black then. So the index is 3. And that's what cube root means, cube root. And just like square root was asking an operator question, the cube root asks an operator question as well. Whereas square root asks what times itself, the cube root asks what times itself 3 times. Okay, so the cube root is asking then what times itself 3 times. Okay, so what times itself 3 times? That's what the cube root is asking. Okay, so when the cube root is asking you that, that's the question. Okay, so that symbol is not just a fun-looking symbol; it's an operator, and you have to treat it like one. All right, so what do we do with that information then? All right, so we have to remember a couple of neat rules about roots and how they work. So let's take a trip down memory lane. And so I'll say, remember, the square root of a over b is equal to the square root of a over the square root of b. Basically, you can separate radical signs in the numerator and in the denominator. So that's just a trip down memory lane that we can take, and that's going to help with the square root of negative 64 over 125. Another thing to remember is some interesting things about exponents and signs. Okay, so we have to consider exponents and signs. So if, let's say I had negative 2 to the second power, is that going to be positive or negative? Right? Clearly, you can see negative 2 is going to be positive. Negative 2 to the second power is positive. Okay? So what if I had negative 2 to the third power? Is that going to be positive or negative? And negative 2 to the third power is actually going to be negative, because you end up with negative 2 times negative 2, positive 4 times negative 2 is negative 8. So what if we had negative 2 to the fourth power? That's going to be a negative times a negative, which is positive times a negative, which is negative times a positive, which is a positive. Whoa. So it's going to be positive. What if we had negative 2 to the fifth power? You know, is it going to be positive or negative? Okay, so it's going to be negative as well. So you see how the pattern goes. Now, this is going to come up with a huge note. This is a pretty big note I'm about to give you right now. So that means, what does this mean? If I have a positive thing, can I take the square root of negative 2? You know, and that's the question. Square root of negative 2? No, that's imaginary, impossible. So that's imaginary. What if we had then the cube root of negative 2? Is that real or imaginary? That is a real number, because a negative times a negative is a negative. So this is totally real. This is very possible. Okay, so the cube root of a negative number is very possible. What about the fourth root of a negative number? That is impossible. That's imaginary. And what about the fifth root of a negative number? Okay, so the fifth root of a negative number is possible, quite real. And the best way to demonstrate that is with ones. Ones are fun to work with. So another quick refresher. Let's say I ask two more examples, right? Mini example. What is the 10th root of negative 1? That means what number times itself 10 times gives you negative 1? Impossible. There's no such thing. It's imaginary. It's actually I, isn't it? So it's the 10th root of negative 1. It's impossible. It's imaginary. But what if we had, the 23rd root of negative 1? All right, so what times itself 23 times gives us negative 1? Negative 1. That's a real number, right? A totally real answer would happen if we were to do that. That is a huge concept, okay? So this what I just covered is very, very, very important. So hopefully if you have any questions about what I just covered here on the video, you can ask me in class, or you can replay this and get your mind right. So now we're going to take this information, everything that you're seeing right now, remembering how radicals work, remembering how I can take the cube root of negative numbers is okay, all that stuff. We're going to take that information and then apply it to our second problem. Okay, so now we have the cube root of negative 64 over 125. What does this mean? This means I can have the cube root of negative 64 over the cube root of 125. Notice how only one of these is negative. It's the same principle that we dealt with slope. You know, if the slope was negative, either the rise is negative or the run is negative. Doesn't mean both are negative, only one of them. Okay, so it doesn't matter which one you make negative, it just happens to be that way. So now we have the cube root of negative 4. And again, the question is, what times itself 3 times? What times itself 3 times gives you negative 64? And if you go over some number crunching or thinking, you will realize, well, that's going to be negative 4. Because negative 4 times itself is positive 16 times itself is then negative 64. And then the cube root of 125, what number times itself 3 times is 125? Hopefully you will come up with 5. Okay, so the cube root of negative 64 over 125 happens to be negative 4/5. And there is our simplified version. How cool is that? That's pretty neat. Okay, so we can take a look at some crazy looking question. You know, the cube root of negative 64 over 125, we realize it's negative 4/5. Okay, so that's how that works. On to number 3 then, right? So here's the third question. Now we're going to find the 4th root of 0.0016. This is nuts now, okay? So now we're getting into crazy talk. Not only do I have to know higher indexes, I have to remember places. Do you know in most foreign country, places is what students learn first. Y'all ever see an abacus? That is all about places. And so, you know, arithmetic is focused on places. That's why our students, we have issues with this because we don't emphasize it enough in our schools. Anyway, not the point. So we have the 4th root of 0.0016. And so remember what the question is asking. The 4th root is asking, what times itself 4 times? What times itself 4 times gives us 0.0016. And you focus on the 16, right? And you focus on the 16. You might be thinking, well, 2, right? Because 2 times itself 4 times is 16. But yeah, well, 2 times itself is 16. Well, then we've got decimals, and there's like a whole bunch of decimals. And so what if you're thinking this? What if it was 0.02, let's say? Is it 0.02? And so you might go down that route, okay? You might be thinking, that was funny, by the way. I just made an intentional joke. Might be going down that route. Good times. Okay, so you might be thinking 0.02 times itself 4 times. So 0.02 times 0.02, that's 4 with 4 decimal places. Just right there is, we can already tell this is probably not going to work out, okay? Because if we multiply this times 0.02, that's 8 with 6 decimal places. And if we multiply that by 0.02 again, that's 16 with 8 decimal places. Holy cow. So that's just too many decimal places, right? That can't be possible. And again, if we understood places back from elementary school, what I'm doing right now shouldn't be confusing. However, I fully understand that for many of you, it might be confusing. So we know 0.02, clearly not the answer. So what about 0.2? Right, so if we try out 0.2, so 0.2 times itself, too many dots, right? So that's 4 with 2 decimal places, boo. And then we do that times 0.2. And that would be 8 with 3 decimal places. Oh, now it looks like we're in business. And we do that times 0.2, and there's our win. Okay, so that's 16 with 4 decimal places. And that's what we need, right? So the 4th root of 0.0016, of course, is 0.2. So we have to be really cool with decimal places and understanding how that works. And I have an abacus in my classroom, so if you want to learn about decimal places, just grab the abacus and look up how to work with an abacus, because I can only do minimal things anyhow. So that's how we can work with number 1, number 2, number 3. Now we got to get on to some crazy, crazy stuff. Okay, so we look at number 4. We have to start understanding more things about that question that square roots ask. So we're going to simplify this now. Remember what the cube root is asking. The cube root is asking what times itself 3 times gives us x to the 6th power times y to the 9th power. And what we can do is play around with a couple of concepts. Okay, we can play around with under the radical and outside the radical. We can play around with a couple of reminders. A reminder of this rule, like remember this. This is pretty important. Remember, the square root of a times b is equal to the square root of a times the square root of b. That's really important. That's really important to remember. Okay, so we can do the same thing here. So we can actually apply that to this. Okay, so we have the cubed root of x to the 6th times the cubed root of y to the 9th. And remember what the cubed root asks. It asks what times itself 3 times. Gives us these things. So you might be looking at x to the 6th. Hopefully you realize that that's certainly not x, because x times itself 3 times is x to the 3rd power, not x to the 6th power. So what is the cube root of x to the 3rd power? What times itself 3 times gives you x to the 6th power? X squared. When you multiply x squared by itself 3 times, you're going to get x to the 6th. And what times itself 3 times gives you y to the 9th? Y to the 3rd power. Right? And if you want proof, or prove it, test it, you can even test it out, right? X squared times x squared times x squared, and then y to the 3rd power times y to the 3rd power times y to the 3rd power. Everything we did from laws of exponents. 2 plus 2 plus 2 is 6, right? That's x to the 6th, and that's y to the 9th. So guess what? We're good to go. It all checks out. So when we simplify that radical sign number 4, that's what we'd end up with. We'd end up with x squared y to the 3rd. Okay, that's the simplified version of that. All right, and now we're going to get into the last bit, which is crazy talk. Or are we? No, I think I'm going to save it for another time. All right, so now I get to the last bit. So now we're going to simplify number 5. We have the 4th root of 81, x to the 8th, y to the 12th. If you were paying attention to the last problem and the last answer, and you look at the question again, hopefully you can see some relationships between the exponents inside the radical and the index, right? That's a little gimme. Okay, so hopefully you can see a relationship. Some things might appear. Okay, so now we're going to think. What times itself 4 times gives us 81? Hopefully you know that the thing that's multiplied by itself 4 times to give you 81 is 3. So we have the 4th root of 81 is 3. What about the 4th root of x to the 8th power? What times itself 4 times gives you x to the 8th power? And you can test some things out, and you will come up with, well, x squared. And then the 4th root of y to the 12th power, of course, is y to the 3rd. Do I get into crazy stuff here? No, not yet. I will. We're going to introduce absolute values, and you'll see why later. So we have 3 times x squared times y to the 3rd. And what's going to happen is absolute values will appear. We'll get into that. May as well. We're here. So the 4th root of 81, x to the 8th power, y to the 12th, turns out to be 3 times x squared times y to the 3rd. And there is our simplified version. So now what I want to do is go back to number 4 and number 5. Okay, so I'm going to do number 4 and number 5 right quickly and then show you a couple things. So number 4, we had the cubed root of x to the 6th power, y to the 9th, and that turned out to be what we thought, x squared y to the 3rd. And then number 5, we had the 4th root of 81, x to the 8th, y to the 12th, and that turned out to be what we thought was 3, x squared y to the 3rd. Okay, so now something weird is going to happen. We're going to talk about something we know of called the principal root. Okay, the principal root. If you remember, and let me go over here. if you remember from basics of square roots, if I were to ask you what is the square root of 4, right? What is the square root of 4? You would say 2, right? And I would say or, right? Or negative 2, right? So technically the square root of 4 is 2 or negative 2. Well, from here we're going to work with what's called principal roots. The principal root is only the positive root. Okay, so the principal root is only the positive root. So from here on out, we're talking about square roots. We're gonna clarify it by saying only the positive root. Now, here's what's interesting. Check this noise. What if I were to ask you? What is the square root of x to the, well, let's say square root of x squared. Okay, well, what is the square root of x squared? The square root of x squared is, of course, x, right? But then we're only dealing with the principal root. So if the square root of x squared could be x or negative x, we're going to call it just good old x. So the square root of x squared is good old x, the principal root. To make sure that this always happens, to make sure we're always dealing with x, to make sure we're always dealing with the principal root, we're going to use absolute value. It's the absolute value of x. And here's why. What if x was actually negative 2, let's just say. So the square root of negative 2 squared. Okay, so the square root of negative 2 squared, we know, is going to be the square root of positive 4, which is 2. Okay, we know that. However, take a look at this. If the square root of x squared is x, wouldn't this be negative 2? Right? So what's happening here? You know, I have like a mental, boop, my brain just popped. If we're looking at this relationship from here to here, the square root of x squared is x, and the square root of negative 2 squared is 2, then how come this is negative 2? So what's going to happen is that sometimes we're going to have to use absolute value bars to make sure that we know that we're dealing with the principal root. Now, on page 363 in the book, there's a very confusing graphic about how that works. And you'll see in more detail underneath that. But here's the deal. If you have an odd root, if you have an odd index, you don't need to worry about absolute value bars. That's just something to remember. If you have an odd index, don't worry about absolute value bars. If you have an even index, time to start worrying about absolute value bars. If you have an even index, okay, if you have an even index, but one of your variables has an odd exponent, that variable is going to need absolute value bars. So technically, when we said that the answer for number 4 was x squared y to the cube, we were good to go. But when we said the answer for number 5 was 3x squared y to the third power, we needed the absolute value bars for y. So odd index, no worries. Even index, so odd index, no worries. Even index, we need absolute value bars for odd exponents. What? That gets tricky. But again, just like everything else, it all works out with practice. Thank you very much.